In this video, we'll explore absolute value equations and inequalities. Now, when we talk about the absolute value, if it's an equation, we're going to take the right-hand side and set equal to the positive of the right-hand side and the negative of the right-hand side. If it's less than, it's going to be a compound inequality. So it's got to be greater than the negative of the right-hand side and less than the positive of the right-hand side. If that had been a greater than symbol, we do that with an OR. With our interval notation, the OR gives us a new interval notation where we have the U in between, which is the union, because we have what happens when it's less than, what happens when it's greater than, and the solution is both of those. So being both of those gives us the U. When we want to solve absolute value equations and inequalities, we want to try to get the absolute value expression by itself and then set up two equations or inequalities, with the other side being set to the positive and the negative. And if we have inequalities, make sure to graph them and provide the interval notation. So here's my first example. It's an equation, so I'm going to take and set the left-hand side equal to the positive and negative of the right-hand side. Just be very careful when you do the negative of the right-hand side that you change both terms. So that becomes negative 9x and positive 12. So I go through and simplify. I'm going to add 12. I'm going to subtract 5x and then divide by 4. So one possible solution could be x equals 5. I need to check it as well, so we'll do that in a little bit. Now over here, just to show the exact same steps, I subtract by 12. I'm going to subtract the 5x, and then I'm going to divide by negative 14, so x becomes positive 2/7. Now let's check both of these solutions. When I plug in 5, I end up with 25 plus 8 and 45 minus 12. I end up with the absolute value of 33 equals 33, and then absolute value of 33 is positive 33. So positive 33 equals positive 33. That's a good solution. Now I look over here. When I do 2/7, my interior becomes 10/7 plus 8 and then 18/7 minus 12. I keep simplifying and I end up with positive 66/7 equals negative 66/7. That's not possible. So 2/7 is not a solution. So in this case, I only have one solution. X equals 5. Now say here's a problem with a less than. First thing I want to do is get the inequality by itself. So I add 4 to both sides. Now since this is a less than, it's an AND problem. So 2x plus 5 is less than 11 and 2x plus 5 is greater than negative 11. Solve each inequality. Subtract 5, divide by 2, and x is less than 3. Now I'm going to subtract the 5, divide by 2, x is greater than negative 8. And remember, this is an AND problem, so x is greater than negative 8 and less than 3. So negative 8 to 3 is my interval, and it's both parentheses because it's less than. It's where I started with. So when I graph it, I'm going to have a hollow dot on 8 and 3, and then I'm going to shade in between, because everything's in between those two values. Now, say I have this next problem. A lot of times people struggle with the idea of the x being on the right-hand side and reading it, because we always want to read from the perspective of x. So I could rewrite it as the absolute value of 3x plus 4 is greater than or equal to 9, because I just flip everything. And that's okay to do if that's better for you. Now I'll read that as greater than, so I know it's an OR problem. So 3x plus 4 is greater than or equal to 9, or it's less than or equal to negative 9. So I'm going to just simplify by subtracting 4, dividing by 3. So it's greater than or equal to 1 2/3. Let's go through this one. Subtract 4, divide by 3, and you end up with negative 4 1/3. So if I look at the inequality here, I have that it's less than or equal to negative 4 1/3 or greater than 1 2/3. So I use my union. The first always lists the less than first. So from negative infinity to my value, negative 4 1/3. It's a bracket because of the equals to. The union is like my or, and then it's going to go from my greater than value to positive infinity. When I graph them, I'm going to graph just my two inequalities. So in this case, negative 4 1/3 down here, 1 2/3 here, and so everything will work except for what's in between these two.